Hello, my name is Bhavan Shah, and in this demo, we'll talk about how you can leverage PX-DR to create asynchronous disaster recovery solutions for your VMware Tanzu clusters. For this demo, we have two different vSphere clusters with Tanzu Kubernetes Grid Service clusters or TKGS clusters running, which already have Portworx installed. The cluster or the data center on the left is our source cluster, and on the right is our target cluster. The first step in creating these asynchronous DR relationship is to create a cluster pair, which is a one-directional object that connects our source cluster to the target cluster. Once we have the cluster pair fully functional, we'll create migration schedules that have schedule policies associated with them, where you can specify the namespace which hosts your application and the interval at which all of this data should be moved from your source to your target cluster. In case of a disaster event, you can quickly log into your target cluster, run the storkctl activate migration command for that specific namespace, and your application will be brought online as soon as possible. Now, when your source cluster is back online, you can create a similar migration schedule policy and a cluster pair object. Now, but this time going from the target to back to the source cluster, because we are performing a failback operation, and repeat the same process all over again. So once your cluster, your original source cluster is online, you can bring back your applications and then run them out of the primary location. So let's see all of this in action. We have logged into a terminal session which has access to both our source and target clusters. We are logged into the source cluster right now, so let's run a couple of commands to make sure everything is looking good. We have kubectl get nodes. All the nodes are up and running. We'll do a kubectl get cluster pair in the demo namespace. This is the relationship that's established already between the source and the target cluster. You can use our storkctl get cluster pair command to get more details, whether the storage relationship and the scheduler status both are ready or not. Now let's deploy the stateful application that we want to fail over and fail back as part of this demo. It's a simple UI based app that leverages a Postgres backend and a Kubernetes web.yaml, which acts as the front end as well. So once we deploy both the YAML files, let's do a kubectl get all in the demo namespace. You can see we have two pods, we have two services, two deployment objects, two replica set objects, and then we have one persistent volume which holds our Postgres data, or which holds the data that persists in the application. Let's navigate to the UI for the application and let's generate some data. So if you can see, this is a very simple app where it generates a Kubernetes logo every time we click somewhere. And this is my attempt at writing the word demo out of Kubernetes logos. So now that we have generated some data that is stored in the PostgreSQL database, we are now ready to create a migration schedule for the demo namespace. So let's check the schedule policy first. We have created a demo schedule policy that copies over all of our data from the source to the target cluster every 5 minutes. This RPO setting is completely user customizable. You can go down as low as 1 minute with PX-DR asynchronous replication. Let's look at the migration schedule. Here in the specification section, we have the name of our cluster pair. We want to include all our resources, so not just data, but also the application config and Kubernetes objects. And we don't want to start the applications on the target site when the data is, or when the migration is first triggered, because we still want the primary site to be active. So that's why the start applications is false. Let's apply the demo migration schedule YAML file, and then we can use a couple of simple commands to look at the status of the migration. So as soon as the migration schedule is applied, it will trigger a migration operation. So you can do a kubectl get migration schedule, kubectl get migrations in the demo namespace. You can also use our storkctl utility and storkctl get migration schedule and get migrations in the demo namespace to get more details. As you can see, we have one volume and 7 different Kubernetes resources that we want to copy over from the source to the destination site. All migrations begin by copying over the persistent volume, and this can be incremental as well. And then once the persistent volume has been successfully copied over and the data is in sync, it then moves ahead with the Kubernetes objects replication as well. To get more details, you can use the kubectl describe migrations command and look at where it is. So as you can see, all of our different objects have been migrated successfully. And if we do one last .ctl get migrations, you will see that the migration is successful. Now let's do this. Let's pretend that our source cluster went down. So we'll suspend the migration on the source side. So any changes that we make on the source side doesn't get copied over every 5 minutes. So we'll to suspend the migration, we need the name of the migration schedule. So let's do a storkctl get migration schedule in the demo namespace. We have the name of our migration schedule, which is site A to site B -migration schedule. Let's do storkctl suspend migration schedule and the name of the migration schedule. We can do a get again to see whether suspend flag is set to true or not. Now let's log out of the primary cluster and then log into the target cluster. Again, if you had an actual disaster event, you wouldn't be able to access your primary cluster or suspend operations. We are just trying to simulate a disaster event, so that's why we had to suspend and log out of the primary cluster. We log into the target cluster and use the same commands to check whether everything is looking good or not. So if we do a kubectl get all in the demo namespace, you will see that the service objects and the deployment objects are already created, but there aren't any pods running. This is because we didn't want our applications to start as soon as the data was copied over. All of the different objects, our persistent volumes, our deployment services do exist, but the pods are only deployed when we use the storkctl activate migrations command for the demo namespace. So as soon as we do the activate command, it will increase the replica count for our deployment object and deploy those pods. We can use the load balancer IP for our Kubernetes web front-end pod and navigate to the application. As soon as our pods are running, we'll be able to navigate to the URL and get and verify whether all the data has been migrated over. So again, the demo word that we wrote in with Kubernetes logos is copied over to our target site. So we saw a scenario where failover from a source or a primary site to the target site was completely successful. All the Kubernetes objects, all the application data, all the persistent volume was moved over from our source to the target site. Now, let's say our source cluster or source data center is back online and we want to do a failback operation. So for this, we are logged into the target cluster, which is our async cluster B. We'll create another a second cluster pair instance, this time from the target cluster to the source cluster. So async cluster B to async cluster A, and then use the same schedule policy. So we have our cluster pair already created, we have our schedule policy already created. We can use the storkctl get cluster pair command to look at the status if everything looks good and is ready for the migration operation. So let's generate some new data before failing it back. So to make sure that any new data that was generated when our application was running on the target site is failed over or failed back to the primary or the source site as well. So let's apply a different migration schedule called failback this time. This basically copies everything that's running on the target cluster and then moves everything to the source cluster again. So just performing a simple failback operation for our stateful application. So we can use the same set of commands to monitor the migration operation: kubectl get migration, storkctl get migrations. All of these are namespace defined. So we provide the -n demo flag for all of these commands. We can monitor our migration using the storkctl get migration -n demo, and then we can describe the migration to look at what's the phase or what's the point where the migration is live right now. So as you can see, all of our objects have been copied over, including persistent volumes, config maps, service and deployment objects, and everything is looking good. We'll do a final command, storkctl get migrations, to look at the status and verify that all the objects have moved over. As you can see, 1 out of 1 volumes and 7 out of 7 Kubernetes resources have been migrated successfully from the target back to the source cluster. So we have performed a failback operation. Let's log out of the target and log back into the source cluster and verify that our application can come online with the new data. So we log into the source cluster, the async-cluster-a TKGS cluster that's running in our primary data center, and we'll use the kubectl config use context command to set the correct context for our async cluster A. We'll do a kubectl get nodes to verify that we are logged into the correct cluster, and then we'll do a kubectl get all for the demo namespace. Similar to the failover operation, the failback operation also doesn't create the pods. It creates my service objects, my deployment objects, but doesn't create my pods till I activate the migration. That's one key thing to remember. So we'll do the storkctl activate migrations command for the demo namespace. And as soon as you execute that command, the replicas for your deployment object are created, which means pods are being deployed. So it takes just a few seconds for the pods to come online, and your service and your deployment objects are already there. At this point, you can see that we have both of our pods that are in running state for the last few seconds. So our application is online. We are just waiting for the service load balancer for the load balancer service to get an IP address so we can access the application again. This is running on a Tanzu cluster with NSX Advanced Load Balancer, so we don't have to manually provision the load balancer IP. It automatically gets it from the NSX Advanced Load Balancer. As soon as we have an IP address, we can navigate to the browser, navigate to the URL, and verify that all of our data, that the new data that was generated in addition to the old one, has been successfully failed back from the target to the source cluster, which in this case it is. So let's make sure all the Kubernetes objects have been deployed, and we can see that pods, service deployments, and persistent volumes all exist on the source cluster. Everything is back online again. That's it for this demo. Thanks for watching.